Side curtain theory. Theories and theories about a region of space in which we live is one face of a larger structure called the side curtain and the interactions between the different planes. The concept of the brane theory proposes that our observable universe, the three-dimensional space we inhabit, is just a surface, or brane, embedded within a larger dimensional structure known as the bulk. This intriguing hypothesis arises from attempts to unify gravity with other fundamental forces, such as electromagnetism, through the framework of string theory and M-theory. In this article, we delve into the theories and hypotheses surrounding the brane theory and the interactions between different branes. Branes and extra dimensions. According to the brane theory, our three-dimensional space is a brane embedded within a higher dimensional bulk. The number of extra dimensions in the bulk varies depending on the specific model, with some theories proposing 6 or even more additional spatial dimensions beyond our familiar 3. These extra dimensions are compactified or curled up to a microscopic scale, making them effectively invisible to our everyday experience. The role of gravity and the hierarchy problem. One of the motivations behind the brane theory is to explain the relative weakness of gravity compared to the other fundamental forces. This disparity, known as the hierarchy problem, suggests that gravity may be diluted or spread out over the extra dimensions. In this scenario, the strength of gravity we perceive is a consequence of its interaction with the brane, while the other forces are localized on the brane. Brane collisions and cosmology. In certain brane scenarios, collisions between different branes can occur. These collisions can have profound implications for cosmology and the evolution of the universe. For instance, brane collisions could give rise to rapid expansions, inflation, or generate new universes with different physical properties. Exploring the consequences of brane collisions and their impact on the large-scale structure of the universe is an active area of research. Brane world scenarios and particle physics. The brane theory also offers possibilities for explaining the properties and interactions of elementary particles. In some brane world scenarios, the standard model particles, such as quarks and leptons, are confined to the brane, while gravity can propagate into the bulk. This localization of particles on the brane can provide explanations for the masses and couplings observed in particle physics experiments. Black holes and brane interactions. The presence of black holes within a brane world scenario raises intriguing questions about their behavior and interactions with other branes or the bulk. Investigating how black holes are formed, how they evolve, and whether they can extend their influence beyond the brane presents a challenge in understanding the interplay between gravity, brane dynamics, and the structure of the bulk. Testing the brane theory. Experimental tests and observational evidence for the brane theory remain challenging due to the microscopic scale of the extra dimensions and the complexity of their effects. However, various phenomena, such as deviations from classical gravity at small scales or experimental tests of the high-energy regimes, could potentially provide indirect evidence or constraints. On the brane theory. Ongoing experimental efforts, such as those conducted at particle accelerators or through precision gravity measurements, contribute to testing the predictions of brane world scenarios. Multiverse and the brane landscape. The brane theory also intertwines with the concept of a multiverse, where multiple branes or universes exist within the larger bulk. Each brane may have its own unique properties, physical laws, and interactions. Exploring the existence of other branes and understanding the mechanisms of their formation and interaction open up a rich landscape for cosmological investigation and theoretical exploration. Cosmological implications of brain theory. The brain theory also has implications for cosmology and the early universe. In some models, the universe is envisioned as a brain that undergoes inflationary expansion, driven by the dynamics of the brain and its interaction with the bulk. Exploring the consequences of brain inflation and its effects on the formation of cosmic structures, the generation of primordial fluctuations,